All right, welcome back, everyone. Today we're going to talk about solving logarithmic equations. And so at the end of this lesson, you should be able to solve logarithmic equations. Now, a logarithmic equation are those that involve logarithms, right? So for example, log base 2 of x is equal to 4. As far as solving these equations goes, if only some of the terms contain a logarithm, we want to condense all those terms down to 1 using those rules, the power, product, and quotient rules. And then we want to convert to exponential form to solve the equations. If all of the terms contain a logarithm, then we're going to condense both sides into one logarithm. So you'll have two, one on the left-hand side and one on the right-hand side. And then use the one-to-one nature of logarithms to solve. Okay? Always check your answers and make sure that you're not taking the log of a negative number, which we'll do. Okay, so because the logarithm is a one-to-one function, if you have the natural log of a is equal to the natural log of b, that tells you that a equals b. Notice we can just kind of drop those logs away. That's what's going to happen in the later examples. So let's start with a simpler example first. Log base 3 of 2x minus 4 equals 2. So in this case, we've got the logarithm condensed on one side of the equation. Right? Notice they're not on both sides. And so the thing we want to do is we want to convert to exponential form, just like we did in section 5.3. So to convert to exponential form, we need to know what the base is. And in this case, the base is 3. We need to know what the exponent is. And remember, when we're talking about logarithms, the exponent always comes after the equal sign. And then we're going to set that equal to what's left. So base raised to the power of the exponent, so in this case 3 squared, is going to be equal to 2x minus 4. Now that we've converted it to exponential form, it's much easier to solve. 3 squared is 9. We can then just add 4 to both sides. We get 2x is equal to 13. And if we divide by 2, we get x equals 13 over 2. So the trick is to write this thing as one logarithm and then convert it to exponential form. So let's try another one. Log x plus log x minus 9 is equal to 1. So now we have two logarithms, but they're on one side of the equation. So we want to condense those down to 1. Using the product rule from section 5.4, if we have two logs added together, we can rewrite them as multiplication. So x times x minus 9. And so what that's going to give us is log x squared minus 9x equal to 1. Now that we have one logarithm, we want to rewrite this thing in exponential form. So we need to know what the base is. Remember, if there's no base, it's implied base 10. And so if we rewrite this equation, we're going to get the base, which is 10, raised to the exponent, which is 1, and that's going to be equal to x squared minus 9x. So moving to the next slide, we've got 10 is equal to x squared minus 9x. Here we have a quadratic function, or a quadratic equation. We can move everything to one side by just subtracting 10 from both sides. And what we get is x squared minus 9x minus 10 is equal to 0. Now we can factor this to solve it. X minus 10 and x plus 1. And then we can take each factor and set it equal to 0. We get x equals 10 and x equals negative 1. Now we're not quite finished because we have to check our answers. If we go back to our original equation, the very first one we started with, log x plus log x minus 9 equals 1. If we plug in 10 for x, then we never take the log of a negative number. So 10 is okay. However, if we plug in negative 1, now we're taking the log of a negative number. And so we can't keep negative 1. And our answer is just x equals 10. So now let's try another example. This time we have log x minus log of x plus 3 equals negative 1. So once again, we have logs on one side, but not on the other. And so we have the log of a difference, two things subtracted from each other. So we can use the quotient rule and rewrite this as a fraction. So log of x divided by x plus 3. Remember, the negative term goes in the denominator. And that's equal to negative 1. Now, once again, we want to convert to exponential form. The base isn't there, so it's understood to be 10. And so we get 10 to the minus 1 power. Right? 10 is the base, negative 1 is the exponent. And that's equal to x over x plus 3. So now we can solve this. Well, first, let's just rewrite 10 to the minus 1 as 1 over 10. The negative exponent just moves it across the division side. And now we're going to take this equation and move it to the next page. And so we get 1 over 10 is equal to x over x plus 3. To solve this equation, we can cross multiply. 1 times x plus 3 is equal to x times 10, or x plus 3 is equal to 10x. If we subtract x from both sides, we get 3 is equal to 9x. Divide by 9. Then we get x equals 1/3. And now we just want to go back and check and make sure our answers work. And so log of 1/3 is okay. And log of 1/3 plus 3 is okay. So both of those are positive. And so we can just keep x equals 1/3. Finally, if there are logs on both sides of the equation, we've got to do something just a little different. Start by combining both sides together. So what we have is log x plus log x plus 4 equals log of 12. So we're just going to take the left-hand side and use the product rule. And if we use the product rule, we can rewrite the left-hand side as log x times x plus 4. Right, just multiplying the two together. And that's equal to log of 12. And so what we get is log x squared plus 4x is equal to log 12. So here's where this one's just a bit different from the other problems. Because we have logs on both sides, and because log is a one-to-one function, that means if you take the log of a and it's equal to the log of b, a has to be equal to b. Every log gives you a unique y value. So what this means is if we got logs on both sides, the only way for them to be equal to each other is if we essentially drop the logs and say x squared plus 4x is equal to 12. Notice this is the only time where the base doesn't matter. In every other type of log equation, the base matters. In this case, it does not. So now we just want to solve this quadratic. We get x squared plus 4x is equal to 12. If we move 12 to the other side, minus 12 is equal to 0. And now we can factor this one too. We're going to get x plus 6 and x minus 2 equals 0. Set both of them equal to 0. Remember that if you can't recognize the factoring, you can always use the quadratic formula. So here if we subtract 6 from both sides, we get x equals negative 6. And if we add 2 to both sides, we get x equals 2. Now we just want to go back to the original equation and check and make sure we're not going to take the log of a negative number. Well, if x is negative 6, and we plug it into the first term, immediately we get the log of a negative number. So negative 6 is not okay. If we look at 2, if we plug in positive 2 for each one, then that works. So we'll keep x equals 2. So one more example. We have the natural log of x plus 8 plus the natural log of x minus 1 is equal to 2 times the natural log of x. So just like before, on the left-hand side, we want to combine using the product rule. So we're going to get the natural log of x plus 8 times x minus 1. On the right-hand side, we just want to simplify using the power rule, right? So the constant in front is just going to become a power. And so on the right-hand side, we get the natural log of x squared. If we simplify now the left-hand side by foiling, x times x is x squared, minus 1x plus 8x minus 8 equal to the natural log of x squared. And so the natural log of x squared plus 7x minus 8 is equal to the natural log of x squared. Once again, because we have logs on both sides, we can essentially just drop the logs and set the other two parts equal to each other. And so what we get on the next, go to the next slide, x squared plus 7x minus 8 is equal to x squared. If we subtract x squared from both sides, they both add to 0, and we're left with 7x minus 8 equals 0. We can then add 8 to both sides and divide by 7. And you get x equals 8 over 7. And so if we go back to our original problem, if we plug in 8 over 7, all of those things are positive. And so 8 over 7 is okay. So at the end of this lesson, you should be able to solve logarithmic equations.